We're going to talk in this part about nutrition for disease, or better titled, nutrition support for disease, both in the case that we're trying to prevent disease from occurring or in the case that we're trying to regress the symptoms of diseases that have already onset. But before we can talk about appropriate nutrition for disease, we have to first explain the disease etiology and pathology, meaning what are the underlying conditions that make it happen, and then what are some of the conditions that exacerbate it and make it really turn into something that's life. Really, all disease boils down to the body and cells being damaged and fatigued and aged. So, the faster we age our body and the faster we turn over our cells and the more damage we cause in the way that we live and our lifestyle, the shorter our lifespan is going to be. It makes sense from a biological and just logical perspective. So, one of the big causes of damage in the human body are free radicals. And free radicals, or reactive oxygen species, are formed in the cell and they cause a tremendous amount of cell damage. Now, we have all sorts of external things that also contribute to free radicals and the formation of those in our cells. We can't control a lot of those things, like our exposure to UV light, at least to some extent. We're going to have a little bit of that. And, even for adequate vitamin D production, like we've spoke about before. We also are exposed by air pollution and radiation sources that, are somewhat out of our control in terms of just our region and our water sources and the types of traffic in urban, suburban places that we live. We also have behavioral or lifestyle factors that contribute, like smoking and poor diet. And we're going to talk more about poor diet and how it contributes, of course, as the theme throughout this lecture, but also just to note that a lot of free radical damage occurs just from normal cell metabolism and using nutrients. So we've talked about how nutrients are used in the body and the byproduct of that. And we haven't really got into so much the outcomes of all of the chemical pathways, but there is an oxygen molecule at the end of all of that is left roaming and by free radicals peroxidized. And that causes these free radicals to be very damaging. And we will see this little symbol for where it hurts the cell along the way and how these cause disease. So essentially, the damage that's incurred from free radical activity causes inflammation. So there is in the cell, as a result, again, of all of that damage, there's a pro-inflammatory response. So your body goes to aid in repairing that cell damage, and particularly the macrophage type. And now this is going to cause also a perpetuated immune response where there's a secondary layer of immune action, and that's going to cause the release of what's called cytokines. And there's tons of different ones, and really it's beyond the scope to go into all the different ones, but they're abbreviated here, and lots of them get in the way of normal, healthy cell function. And really it's in a mechanism to protect our body, but chronic long-term inflammation from chronic long-term free radical damage, obviously our immune system gets fatigued, and the overproduction of these cytokine contributes to like poor conditions in the cell that can lead to cancer and heart disease and diabetes. So that's kind of where we're going to go. So how heart disease is onset is through a process called atherosclerosis. And some people refer to this as really all boiling down to endothelial dysfunction. And what the endothelial is, it's the lining of the vessels in the body. So they're lined by the endothelium, and then underneath that is the smooth muscle layer. And of course, just like our muscles to contract, that's what relaxes and tightens the blood vessels. So that endothelial lining and that smooth muscle that causes restriction and dilation of that vessel are referred to as proper endothelial function. So when things go wrong and there's dysfunction in the endothelium, a number of things happen. So first off, there's an accumulation of fat, and they start being, like I said, peroxidized by those free radicals, and this is going to cause mitochondrial and cell membrane damage. So ouch, now these things are trying to break down and not have their integrity, and this has all sorts of effects on how good and upright the membrane is, how fluid it is, and how good its permeability is in terms of, is it letting in and out what it's supposed to. And then in these later stages of atherosclerosis, because I forgot to say, but this occurs over many, 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 many years of time, and you can never really quantify the exact timeline because it just depends on lifestyle factors and genetic factors. But this later phase of atherosclerosis includes thrombosis, which is where now we're in this endothelial dysfunction, really in the endothelial dysfunction phases, and you see a lack of nitric oxide production. And you'll understand more about these terms as we revisit the point 3 section. But again, I'm explaining here how we're going to get to this diet point in a minute. So we have a lack of nitric oxide function, and this doesn't let our blood vessels dilate. So now we have that chronic hypertension. Another thing that happens is insulin resistance. So because of all of those cytokines, it causes a blockage of the action of insulin. Now, as an effect of the nitric oxide system not working, as an effect of insulin resistance happening, now we're using more fats in the cells and we have more oxidative damage. So it really is a cyclical thing. And every point in this lecture, you could go chicken or the egg on the order you present these related factors. And then because of all that damage, like I said, now you've got this inflammatory response where you have the macrophage infiltration and cytokine infiltration, and now everything's just messed up. So let's talk about how that leads to the onset of cancer. So what? How does it lead to cancer? So obviously we have genetic perturbations, however you say that word, that make us more susceptible to having cell mutations that lead to cancer. We also have carcinogens, both in our environment and including some in our diet that we'll briefly touch on, that also contribute to genetic mutations. And again, damage to DNA from all of those different free radicals. So they're banging into the DNA, we're having damages, and now we're having abnormal cell division because of DNA damage. So cancer starts really as just a mutation where the cells start to abnormally divide. And this leads to this hyperplastic phase where cells are really going crazy out of control. And now we get into this section where we're seeing a little bit of metabolic contribution. So insulin resistance. We're not able to use insulin very well, and really a lot of people think that this kind of contributes to the certain progression of certain types of cancers because just those inflammatory and yucky conditions from insulin resistance cause the cancer to really accelerate in its growth. And then you have full-blown malignant cancer, which is the type that ends up being fatal, and also the type that metastasizes or neovascularizes, meaning it grows blood vessels and moves to other parts of the body. And so we're not going to get crazy in depth into the stages of cancer. We'll peek a little bit about it in the GI cancers that we discussed, but essentially cancer is abnormal cell growth, typically starts with some genetic mutation, and that typically starts to become because of carcinogens and genetic factors that we were born with. And the progression is a lot of times more controlled by dietary factors. And endothelial dysfunction, which we just talked about for atherosclerosis and heart disease, is also related to tumors moving, which is oftentimes what makes them fatal. So we'll get into more detail in a moment. The metabolic syndrome. So if you look at really like disease. So the metabolic diseases, and we haven't specifically introduced diabetes yet, but it's one of these that's also in this realm. But all of the underlying or the underpinning factors for atherosclerosis, heart disease, cancer, diabetes, and even lots of other mental diseases like dementia and Alzheimer's are related to metabolic factors or things that have gone wrong in the way that we process nutrients in the body. So if you look here at what's called the metabolic syndrome, it's classified as, and if you have 3 out of 4 of these factors or symptoms, then you technically have the metabolic syndrome. In the metabolic syndrome, you're much likely to have a higher incident or higher likely onset of cancer, heart disease, and diabetes. So I decided to organize this by looking at the underlying factors, and a little outside of those, inflammation, which is, that concept of we've got now this macrophage, we've got this pro-inflammatory response, we've got this macrophage infiltration in the fat tissue, chronic inflammation, right? And then we also have that endothelial dysfunction we described causing hypertension and that persisting high blood sugar, and of course all overmasked by insulin resistance. So these are kind of the underlying terms and factors that lead to these diseases. And really the big one, and why the cloud is the biggest, and in fact I'll go back and show you again, is insulin resistance, is because this one's the big dog in terms of how inflammation and cytokines and things are related. So let's see. Oops. I think I went ahead. Oh, no, I did. So if you have a really, really big fat cell, you have adipose tissue dysfunction. So people that are overweight, and this is all going to connect to our lectures on weight loss, is when you're overweight, you have dysfunctional adipose tissue that causes inflammation. That causes that release of cytokines. And this is also happening in the blood vessels because of endothelial dysfunction. Now, what this causes is when the pancreas releases insulin, like in a normal healthy person, it doesn't work because the cytokines, and with a long explanation behind it biochemically, cytokines make you insulin resistant. So they stop insulin from being effective for a number of postulated theories, from insulin receptor things make insulin not work at the fat tissue, muscle tissue, the liver, and even in the endothelial tissues. So, long story short, insulin resistance is the big bad guy in this, which leads to chronically high levels of blood sugar. Because if insulin isn't working, the sugar isn't getting into the cells, then you have it left in the blood, right? So chronically high blood sugar levels, and that's going to cause chronically high cholesterol production. Because if you remember when we talked about fat, I don't know if I really went into too much detail on carbs or I was saving it for this, but excess carbs and sugars in the diet, when we don't have anywhere to put them in terms of glycogen storage, we send them to the liver and they're turned into fats. And those fats are coming out as cholesterol that go around in the body and get oxidized and cause damage. So that chronic high blood sugar leads to chronic high cholesterol production. And altogether, it's going to lead to that chronic reduction in nitric oxide production and ensuing hypertension because the vessels just can't relax. So, and you can look back at the metabolic syndrome, hypertension, hyperglycemia, visceral adiposity, and dyslipidemia, and see how insulin resistance is really tied to all of those functions. And again, you could insert the chicken or the egg on every concept presented here. I could have started with dyslipidemia and how that trickles all the way down. So every angle works on this. They're all related factors, which is why the syndrome has these little arrows they're all interrelated and they exacerbate each other. So let's look at the dietary control for disease. And let's also discuss here why I diluted it to those underlying metabolic abnormalities instead of going nutrition for heart disease, nutrition for cancer, nutrition for diabetes. Because to be honest, it's all the same diet prescription. Because if you can reduce inflammation and you can reduce that inflammatory response and insulin resistance, then you're going to mitigate all sorts of types of disease risk, and you'll learn that. So really it's about fat reducing. We don't want to have too much fat, so we have to have some kind of a way to reduce that fat by calorie restrictions, and you can learn about that in the weight loss section. What really we're looking at in a disease prevention diet, especially in terms of heart disease and vessel diseases, is getting rid of the fats in the blood, getting rid of the sugar in the blood, getting rid of the fats in the blood. So lipid lowering diets are really modeled after the Mediterranean format, which is limited in saturated fats and really boasts monounsaturated fats and also omega-3 fats. I don't have omega-3 up here because there aren't any real tight guidelines outside of the regular healthy person's DRI, which we've already discussed. So extra special guidelines for fat or lipid lowering, again, are those monounsaturated ones. And then also something you've never seen are plant sterols, which are found to be added in 2 to 3 gram doses daily. They help lower blood lipids as well. Glycemic control is another big factor in the diet to prevent and regress symptoms of disease. Basically, foods that have a high glycemic response cause a really high insulin response. And we'll get more into this, but insulin responses are pro-inflammatory. So if we can limit that glycemic response by modifying the types of sugars and making sure we have fiber and soluble fiber, we can limit that glycemic response and that inflammatory response. We know very popular and with pretty good certainty that blood pressure lowering diets through sodium reductions are effective. So the DASH diet is the best model here, which is what you can see. It's 1,500 milligrams a day, and that's been shown to lower blood pressure in a relatively short amount of time. So these are the main factors in preventing disease. Now we'll briefly talk a little bit more about, if you already have cancer, certain things that may help in terms of your daily food intake, but there aren't any real specific nutrient levels for cancer per se, or nutrient levels outside of what you see here. Now, there's lots of topics and research on phytochemicals, and phytochemicals are plant compounds that have all sorts of perhaps disease preventative functions. Now, there's classes that have been really highly studied for heart disease, like the soy isoflavones the oregano sulfur compounds, like in broccoli. These have been studied for cancer and heart disease. In fact, most of these compounds I decided to show out of hundreds, that were listable. These are kinds that have been highly studied for both heart disease and cardiovascular disease. And most of these, though, in outside and in isolation, outside of the whole plant food, don't have like crazy disease protective effects. So you'll see good research where it's promising, or in vitro or in an animal, it shows really good hope for being a great antioxidant, or a great anti-inflammatory compound, or it's a gene inhibitor like resveratrol. We'll talk about it. It inhibits those cytokines from being produced, possibly. But again, we're not seeing that have a big systemic outcome on disease prevention. We're seeing that more with the whole foods, which we'll talk about in the point 2 section. So, point 2 section, what is healthy? It is obviously not easy to take all of this information and put that together to real foods. So, a lot of different programs and organizations have tried to do this. For instance, like the healthy food things, where you have to, if you use the word healthy, it has to meet these criteria for fat, saturated fat, etc. And I also like the healthy claim because it also includes those extra good nutrients. So, it's not good enough to just not have the bad ones. It also has to be nutrient rich in the good ones. You'll also see the Heart Check program, which is at grocery stores, low fat and low salt claims, low zero trans fat claims. So we don't have to go into detail. You've seen most of these before in looking at the fat lecture, but here they become more important because if you're following a really restricted diet that's low fat, you can just look for these things on foods and it helps pick. Specifically this Heart Check one. These ones have gone through a certification program and they have met these criteria so that, soups are a good example of areas to look for this. They're going to be low sodium and meet all those good criteria for fat. Now, looking specifically at the food groups, because I think we've stuck pretty consistently in doing that across the way, so we'll stick with that theme. For the food groups, for the protein group and the milk group, you're going to want to make sure that those are lean and low fat, and we're just talking generally at this point. Fruits and vegetables and grains should be whole and with a high variety, so we're not wanting to see juiced and extracted and refined products in this category. And generally speaking, your fats and oils should be liquid-based. Now, looking a little bit more detail into the fat guidelines, they should be mostly monounsaturated fats, which are, and not mostly, just the highest proportion possible. As long as the fats are unsaturated is the biggest thing, but monounsaturated fats are better. And we'll get into why in a few, but that's going to come in the form of different types of oils that we can use to cook and dress our salads, and essentially polyunsaturated fats as well, like the kind from plants and like the kind from fish and seafood sources, where we have our direct sources of EPA and DHA, which again, only in animals can that happen because we have those enzymes to do that. So we get the linoleic and alpha linoleic from plants, and then animals go and convert that to EPA and DHA, or preformed omega-3s. Let's take a look here at the protein group in a little bit more detail. So we want to make sure that this guy has no added salt. And we'll look more closely at salt in a second. But the milk group, big thing here is no added sugar. A lot of our dessert foods are high in sugar. And both of these groups should not feature a whole lot of saturated fat. And again, we'll go into why. Looking a little closer detail at the titles of these fatty acids, you've got your butter fat, your coconut fat, animal fat like stearic acid, and then obviously we take milk from animals and convert that and extract only the fat out of that to make butter, and then we use that butter and those different types of saturated fats to make all sorts of products that we like, French fries and chips, and that we use grains and fruits and vegetables for. So for these guys, the big look at is no added fat and no added salt, and that's going to keep you healthy in those food groups. The reason we want to emphasize the no added salt in over here in both the protein, milk, the protein actually and the milk, protein, milk, and fruit and veggie and grains, really all of them. Why we're emphasizing the no added salt is because over here you can see that 2/3 are from these processed meats. The meat here, the pizza meat, the cold cut meat, and the burrito taco meat, and then also the grains. So these are high salt grains, breads and rolls. Here's the bread, here's the tortillas, and the pizza crust. So we we put a lot of salt and sodium in our breads to preserve them so that they don't mold, and then the lunch meats also to preserve them and to flavor them. So the two together are just monstrous nightmares. And soups are canned, so they have to be preserved too. So in those areas, that's why we're talking no added salt. In the fruit and vegetable area, lots of fun stuff with antioxidants and what we call the ORAC score. So the ORAC score is how powerful a particular fruit or vegetable or super nutrient is in reducing free radical activity. So these are great high ORAC scoring fruits and vegetables that I have showing in each of the color groups. And so the big thing with fruits and veggies is to get them from all color groups with rich ORAC scoring produce. Also garlic, which is in the white group, isn't showing up here because white bubbles wouldn't work, but garlic is in the white group, and so are other ones like in that family of indoles, onions, and hickory roots, and all sorts of other ones. Cruciferous vegetables like the dark green kinds feature anthocyaninates, and these are a compound that have been studied for heart disease and cancer, but that are really high in these vegetables showing. And then there's all sorts of superfood compounds and phytonutrients in teas, especially green tea, because green tea hasn't been overly oxidized. So a lot of these compounds are still active. So green tea, mainly what's been studied is EGCG, which is the one on the top, but it's really high in green tea, and it's thought to maybe help with certain aspects of disease prevention. Across these groups, we're wanting to feature foods that are high in fiber, especially fruits, vegetables, and grains. And we're going to want to make sure that we're paying attention to sterols for disease folks, especially if they have high cholesterol levels, because it's been shown that sterol-rich foods, mainly the main food studied for its sterol content is soy, to be honest. But I put nuts up here because most recently nuts have been approved by the FDA to use that claim for may prevent heart disease. So I wanted to highlight that one. But yeah, sterols are high in soy and in nuts. And you can see pistachios are great, and they have a beautiful monounsaturated to polyunsaturated profile. And again, we'll go into why monounsaturated are better, but they are. And also they have a good amount of fiber, and not as much as almonds, but almonds don't have quite as much of the sterols. So pistachios are the best nuts, in my opinion, on this one. Some low sodium foods to feature, and we already discussed sodium just a little bit, but just to kind of point out again, you're paying attention to getting 1,500 milligrams a day or less. And we've already discussed glycemic foods. So again, you're focusing low glycemic foods to trigger low insulin responses. If you have cancer and you have mechanical eating issues, a lot of times they'll prescribe clear or full and soft liquids. And really this is for any disease, maybe people who are post-surgery and can't, chew properly. But these are the different therapeutic diets for any types of mechanical issues that someone may have. And a lot of times with chemotherapy, there are mechanical eating issues, especially if it's radiation or chemo to the throat or any kind of the chest area, anywhere in the abdominal cavity. And then some of the things that we can highlight in this area, especially for cancer patients, we're seeing a lot of, the supplemental beverages, breakfast and meal replacement drinks that are super fortified. And then real easy things like cream of wheat and cream of rice, and with added things in it like, the non-fat milk solids that we've talked about, or even wheat germs sprinkled on top, just really getting them to be nutrient dense but easy to eat and digest. And then this is a pretty successful, fun recipe that's pretty inexpensive too. It's just one of those nice ones that's nutritious, it's balanced. It also helps with maybe discomfort in the mouth from radiation therapy. So let's take a look at transformation. So we've taken a look at the guidelines and the parameters for making sure that your diet is, as preventative as it can be, or also to regress some symptoms of disease. But let's take a look now at the details, are a little closer look. So up left, it's showing proper endothelial function. Insulin perfectly binds. We have this reaction that is initiated by nitric oxygen synthase, an enzyme, and there's nitric oxide being produced. Nitric oxide in the healthy endothelial cell causes a vasodilation or a relaxation. Now, this is super important for nutrition because not only does this facilitate delivery of glucose to all of those different cells that need it, but it also stimulates glucose disposal. So it's important for the blood to get rid of the glucose just as much as it is for the tissues to get it. So let's take a look at why insulin resistance and chronic hyperglycemia are going to lead to problems here. So this is going to cause a big time stopping in the synthesis because insulin, again, triggers that reaction. So there's no nitric oxide synthase reaction. Therefore, nitric oxide isn't produced. This uncoupled eNOS causes production of free radicals. So now we've got vasoconstriction because nitric oxide was not produced, and we have free radical production. In addition, because we cannot get any glucose into the cell, we also have an increased production or use of fats, and that's causing more oxide or free radicals to be produced. So free radicals, free radicals, free radicals, which is again going to ignite that inflammatory response like we talked about, and this is going to lead to a cascade of other types of events that get us into trouble in the smooth muscle or the muscle right behind the endothelial. And one thing, for instance, is it causes this proliferative thing where the cells are overgrowing now, and that's just something healthy our body is trying to do in that inflammatory response. But again, the chronic long-term over time proliferation leads to buildup and big time plaque. And then in addition, in the platelets, which are coming by in the blood and sticking to the endothelium, they're producing this inflammatory thing called TXA, which causes more constriction and it causes adhesion. And this works, we won't get into detail, but I can't not do it. It's mentioned, this includes vitamin K. So the clotting components or the clotting factors in the platelets have something to do with this TXA reaction. So all together, what do we have? We have a big problem in those cells that line our vessels, and we have plaque. And that plaque is the characteristic atherosclerosis. Eventually that plaque breaks, and that's how we have strokes and myocardial infarction deaths. So let's take a look over here at the pro-inflammatory response in the cell membrane. So taking a close look, we can see here our lipid bilayer, and we can see what the little green dots are representing are glycosylated or sugar in the cell membrane. So this is a little lipid bilayer. Now, just in normal cell turnover, we break these down, and by action of an enzyme called phospholipase, we break these down to use these for fat or for fuel. So in the instance that we've been describing, under the conditions of insulin resistance, we're breaking down our cell membranes to use those fats for metabolic fuels. And in the presence of insulin and in the presence of insulin resistance, that reaction leads to the breakdown to arachidonic acid, which in simple terms is pro-inflammatory. So that conversion lends itself to producing the eicosanoid thromboxane, which, let me take you right back over here, is TXA. So you can see that in the presence of where you have a whole lot of double bonds here, and I'll get to that in a second actually, I'm jumping ahead of myself, you have a breakdown, normal breakdown to use these sources of fat for fuel in the cell, but in the presence of insulin and insulin resistance, that will favor production of arachidonic acid and the eicosanoid TXA, which again promotes vasoconstriction. So that's bad, and that's a pro-inflammatory reaction. Now, how that's related to cancer and is again through the relation of cytokines. So we kind of already looked at this, but just in a little bit of a different iteration. One, I think a lot of it stems from visceral inflammatory responses. So visceral tissue are big time producers of cytokines because it produces leptin, and leptin produces, triggers cytokine production. So high big time visceral dysfunction leads to the overproduction of cytokines. Again, that causes insulin resistance. We looked at that like second or third slide in. Now, here's how it can help cancer live, because insulin resistance is going to cause, again, that perpetually high blood sugar and also that perpetually high cholesterol. Well, the cancer tumor likes that. The cancer tumor loves to use glucose, and the cancer tumor also needs LDL, and more specifically a lipoprotein on it. So having those conditions favors the survival of the cancer during that proliferative phase. And then in addition, and even worse, the insulin resistance causes endothelial dysfunction, which you'll see right here, and this causes angiogenesis. So it allows the tumor to, because the host conditions are this way, it allows the tumor to, for itself, go ahead and vascularize. And it's again, because of our insulin resistant conditions that have all those cytokines laying around, and the cytokines are allowing the tumor to do that, in simple terms, hopefully simple terms. So that's how inflammation can, kind of trigger cancer. Additionally, in looking at cancer, we see a lot of cancer treatments that lead to things like dry mouth and vomiting, and even other simple gastro things we've talked about before, like constipation and diarrhea. But we also see something more significant with the esophageal pressure, or that reflux disease we talked about. That is one of the big leading causes of esophageal cancer. And really, I'm jumping ahead, but also why overweight and obesity, we're seeing more of a link there, because that increasing that fat around that area pushes that stomach up, makes that reflux, and lots of overweight people have reflux, and that leads to esophageal cancer. So the picture is just kind of showing the stages of esophageal cancer. And then in the stomach, we see carcinogens from like red meat, processed meats cooked at super high temperatures. They make all sorts of toxic chemical compounds. And you wouldn't go into all of them in a class like this, but they make toxic chemical compounds that boil down to forming nitrosamines, which in the stomach can lead to stomach cancer. And then also a lot of the things down in the large intestine are fermented by bacteria, and those lead to carcinogen productions. And those carcinogens can also, of course, just make those cell environment gross, so that the DNA mutates, and so that abnormal cell growth starts. And you can kind of see just how it progresses into the tissues of the colon right here. And this will be important in a few minutes when we talk about how we diagnose colon cancer. It projects way, 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 way into the intersection of the ileum. So let's look at the outcomes. In simple terms, nutrition for disease, I boiled it down because it can be boiled down. If you look at the main protective features, anti-obesogenic, low glycemic, antioxidant, lipid lowering, anti-hypertensive, and anti-inflammatory type diets, right? I listed here in columns, and I would never want you to like memorize all of this. It's just a summary of what I'm getting at with all of these, what nutrients we're targeting for those types of protective diets, the mechanism that it works, and maybe even a little about the target tissue it works in. And what you can see is that all of these have been shown to help prevent cardiovascular disease, and most of them have also been shown cancer preventative. Now, outside of the hypertension, but some would even say that hypertension also leads to certain types of cancers. It just isn't as established. For instance, high blood pressure has been found linked to kidney cancer, and even certain cancers of the bladder. So just more proven are the ones that are bold, and the ones that are showing. And then diabetes. These types of diets have been shown to improve both risk for onset of diabetes and preventing diabetes symptoms once you already have it, maintaining glycemic control. So anti-obesogenic, let's talk more about that function. Why is that important? Because the fat tissue, like I said, it secretes leptin. Leptin loves making those cytokines, and so chronic long-term inflammatory states, chronic long-term cytokines, not good. Resveratrol, you might have heard of it, but it is a supplement that is taken, and it may have an effect on reducing the gene activity so that these cytokines aren't produced as much, and that is helpful. But the research is definitely still inconclusive if that works more than out of the petri dish and in the animal model. Looking at the antioxidant effects of diet and controlling what we eat in that way, what you can see is this is what it's supposed to look like when you have vitamin C in the cell, and when you have vitamin E embedded in the membrane as part of that lipid bilayer, and you have glutathione, which is we make that antioxidant in the body. Of course, the C and the E we get from our diet. Glutathione, we produce it in those membranes. If all those are there, you're money, because your glutathione recharges vitamin E, and vitamin E recharges vitamin C, and there's just this nice electron transfer that keeps those free radicals neutralized, and so you don't get that damage. Now remember, if you don't get that peroxidation damage and all of that boo-boos to the lipid bilayer, then you don't have that anti-inflammatory cytokine response. So that's a great thing. Additionally, and this is where we get to the part about the monounsaturated fats in the membrane. I kept wanting to bring that up earlier with pointing out those double bonds, because if you have a lot of double bonds, they're more susceptible to free radical oxidation. Of course, if you only have one double bond, it is less acceptable. So one double bond still allows for that nice membrane fluidity that we want, which is why we hate saturated fats, because it doesn't provide that fluidity. But the mono, it gives that nice fluidity that we need, but it isn't so much so that it's susceptible to like bam, 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 tons of peroxidative action. So looking a little bit closer, also monounsaturated fats, when they're broken down, when insulin is not around, it is also antihypertensive, because omega-3 fatty acids broken down in the cell membrane are converted to an eicosanoid that is anti-inflammatory. So we said before that when insulin is around and you have these certain types of fats in that membrane, that it produces bad eicosanoids. Well, in the presence and when there's monounsaturated fats and when there are omega-3 in those membranes, it is in favor of producing DHA and EPA. And these are these are precursors to eicosanoids that are antihypertensive because they promote vasodilation. So again, we're just kind of recapping why we do antioxidants and why we do monounsaturated fats and why we do those omega-3 fats, because they're anti-inflammatory and antihypertensive. And that's why we also see supplements for omega-3 taken in the markets of cardio prevention. And then we also see garlic being studied because garlic is supposed to favor the production of these healthy eicosanoids that promote vasodilation. So that's a little garlic heart disease link. Diets that are in control for disease also are pro-glycemic control. So you can see here something we haven't really talked too much about, but just meal timing, just in terms of if you have smaller meals, it causes a lower insulin response and a more stable blood glucose level. You can see here same kind of image, except that now it's showing in a little more detail the bad effects of that high glycemic diet is really the low glycemic response after eating. So several hours after eating, you're hungry again. And so again, it's kind of that vicious cycle of, the brain's going to sense hunger when blood sugar levels are low. So not only the problem of the hyperglycemia and hyperinsulinemia, but also that following hypo later when you're hungry. This is an antioxidant. Why? Because like we said, when insulin is around, it favors the production of that arachidonic acid, which is a pro-inflammatory marker. It is also anti-inflammatory. Actually, I just covered anti-inflammatory through the conversion to arachidonic acid. It's an antioxidant because if you don't have a super high blood sugared food meal, then you don't have it all being taken to the liver and converted to cholesterol that's oxidized later in the vessels. So lower blood sugar response, lower cholesterol production, way less oxidation in those vessels. And then it's also lipid lowering for the same reason. Less hyperglycemia, less has to go to the liver to be converted to cholesterol. So having a diet that's low glycemic is a big deal in terms of how much it can do for disease prevention. And if I could really emphasize any important concept in the whole entire thing, this is why everybody says stay away from refined and high sugar foods for disease prevention, because those types of foods lend themselves to this big time insulin response and triggers these three things that are really the underpinnings again of that syndrome and those diseases. Lipid lowering diets are really centered on having low fat because low fat will mean less bile. Bile is not great. We don't want a whole lot of bile traveling to the large intestine because it can sit around, get fermented, and turn into carcinogenic compounds. So we don't like a lot of bile. So low fat helps less bile production and, of course, less fat absorption, which is great for lowering lipids because we don't have to worry about how much is going to the liver to be put in cholesterol. Fiber and phytosterols, these bind to fat and cholesterol and bile acids down here so that they're excreted. The more fiber and phytosterols that bind to those fats and bile, the more bile that'll be made by the liver, and that, of course, reduces blood cholesterol levels. So lipid lowering diets really are centered on lowering the fat and increasing fiber, and in some instances, including phytosterols. In the GI area, we're also seeing a protective effect of diets high in vitamin C have been shown to bind nitrosamines, those carcinogenic compounds we briefly introduced before. They come from red meats and come from cooking meats and foods at high temperatures and from preservatives in the meats that we eat and the processed lunch meats. So vitamin C in conjunction with these type of diets helps prevent the formation of nitrosamines. It also helps in the instances of at-risk populations, like those with H. pylori, who are at much higher risk of gastric and stomach cancer. Looking a little bit closer at some of the dietary compounds that are suspected to be protective for the GI cancers, including gastric, esophageal, and rectal area. Gastric meaning stomach, sorry about that. These are the compounds that have been studied, and the bolded are the fruits and vegetables. So 5 and 9 today, 8 vegetables and fruits combined each day were shown to be colon cancer preventative. So that's really the only thing that has a pretty probable cause. Everything else is probable, but not, or actually not, I shouldn't say probable. There's evidence. So the bolded ones are probable. The other ones, there's evidence to show that it could be protective. And then there's all sorts of other compounds that have been studied, but there's just not enough evidence to have it up here. Let's take a look at the feedback or how we're doing on our diet in terms of cancer prevention and cardio prevention and diabetes prevention. So the first thing we're going to look at is an anthropometric measure, and it is ran on body weight and reductions in body weight, specifically from a condition called cancer cachexia, which is when you have advanced cancer and you basically stop eating so much, and it leads to a condition that has, all of these little circling bubbles, all of those conditions. One of the biggest features is weight loss and sarcopenia, the two showing on the top. And anytime that someone loses a significant amount of their body weight, it can be diagnosed as cancer cachexia. It's more than 5%. And the problem or significance of this is that people that lose a significant amount of weight and have cancer cachexia don't survive as long. So it really helps if you can preserve body weight. And so one anthropometric measure is just body weight in terms of how we can diagnose or assess how someone's doing on their diet. Because again, if they're dropping weight, then we need to make sure we're taking a look at what they're eating and how many calories they're getting, making sure that they're getting those proteins they need to preserve proteins from being broke down. Because if we slip into cancer cachexia too far, it greatly reduces the lifespan. It cuts it from almost 2 years down to less than 6 months. Taking a look at, so we know also anthropometrically that body size, body fatness, obesity is definitely related to onset and etiology and pathology of diseases. But I just wanted to show you guys on this, it's showing the relationship between BMI and waist to hip ratio, which we've briefly looked at, to coronary heart disease risk. And you can see that in the high risk zones, that the waist to hip ratio are really strong indicators for cardiovascular disease risk. So again, I know we've looked at this, but it's basically a measure of around the waist, around the hips, and in a ratio, and then you're classified here. So again, what we're looking at is what are some of the measures that we can take to give us a gauge of our balances with our nutrients. Are we consuming too much, like in the case of our waist to hip ratios too high? Or are we not consuming enough, meaning are we not getting enough calories to maintain body weight to live longer now that we have cancer? Being overweight and obese is also specifically related to cancer, many types of cancer. We've seen the ones in pink are the ones that are pretty convincing evidence that they increase greatly the risk of developing those types of cancers. And then you can also see dietary factors, and we've introduced them a couple times now, but you can see them here. The ones that are most related to your high intake of these compounds, it is probable that it might lead to an increased risk of those particular types of cancers. And you can see alcohol, a lot of probable risk to a lot of gastro cancers, oral, esophageal, liver, and breast are linked to high alcohol intake. And then again, those preserved and red meats that have that chemical reaction to heat and to digestion, those are also increasing risk of esophageal cancer and even cancers of other areas of the colon, just not with scientific significance. So lots being done to learn about that. And of course, these are coming in a different type of measurement. So instead of overweight and obesity like anthropometrically, now we're talking about asking people what they eat and going, oh my gosh, if they eat, a preserved lunch sandwich every day, then they could be increasing their risk for certain gastric cancers. Taking a look at other biochemical measures, cholesterol levels. So we're hoping for cholesterol levels to be low. Low cholesterol means low levels of oxidation. And we talked briefly about the stages of atherosclerosis. Well, early on, that LDL is getting deposited at those arteries, and that's getting oxidized. And that oxidation causes damage and plaque buildup. And so if we can keep those HDL or those cholesterol levels low, it's a good thing. And also HDL levels, which HDL goes around and picks up LDL from the arteries so that it's not oxidized. So we want our HDL levels to be super high, and that way we know that it's going around and scavenging or picking up all of that extra LDL and reverse cholesterol transport, taking it back to the liver. We also see a measure that's commonly used for assessing how control someone is of their blood sugar it's called glycosylated hemoglobin. So we take someone's blood, we centrifuge it, and we can look at the amount of their red blood cells that have sugar attached to them. And anything more than 7%, it puts them at higher risk for all of the other underlying disease conditions. High blood pressure, so anything in that ideal zone is what we're looking for. Anything high, you got to go back, look at sodium intake, look at fluid intake, look at potassium intake. Again, looking at obesity and body fat levels, because that's underlying many of these. And then looking at some diagnostic feedback measures. So far the ones we've looked at are our standard anthropometric biochemical clinical measures that are looking at screening. Like, so you go to the doctor and you get screened for those things. But what about if you're being diagnosed with cancer or being diagnosed with heart disease? So for colon cancer, and I couldn't go into the diagnostics for every type of cancer, but for instance, colon cancer can be diagnosed using fecal samples where they look for blood. And so these fecal immunochemical tests look for occult blood or blood in the stool. And the blood in the stool is from where the polyp or the adenoma is sticking super far out into the colon, like we showed on that picture, and it causes rupturing and bleeding of the tumor and of regular healthy cells. So that bleeding can be detected in the blood, and you can't otherwise see it. And that blood is sometimes used to diagnose cancerous or even precancerous adenomas. We can also see this method being used to go down into the gastrointestinal tract, and it's literally like a sponge. It pulls out cells, so it's like a biopsy, and then they can look at those cells under a microscope and determine if they're healthy or tumorous cells. And then diagnosing heart disease is something that we can do using physicals, like listening to the heart rate. Sometimes we'll use EKGs and looking at their pace of a person's heart and how it dips and all kinds of things, like this is the filling up of the heart and the pumping of the blood out of the heart. And by using and comparing those to standard values, we can find abnormalities and diagnose heart disease. My favorite are stress tests. And this is like what an exercise physiologist does. They'll put people on a treadmill or give them some kind of exercise-induced stress or even medically induced stress, and they'll monitor their heart rate responses and their other cardioventilatory responses like blood pressure, and make sure that all those responses are normal and good and healthy, so that in the case they are imposed with exercise stress, they're not going to like die. So those are some of the diagnostic tests for heart disease. And that's all I have. So hopefully you have a sense of the general basic diet for disease prevention and regression, a little bit about the foods that go with those guidelines, a little bit about why and some of the underlying reasons for how our body processes nutrients, and some of the functional roles or outcomes of a good, healthy diet, and some of the ways that we measure those things. Thanks for listening.